Okay, so this review is meant for my geometry students. We have a quiz coming up on Thursday covering Chapter 5. So I have several problems to go over with you covering the different topics in Chapter 5. First, let's talk about triangle mid-segments. So here we go. We'll do 43 first. It'll be part A. So in this picture, BE is 2x plus 6, and DF is 5x plus 9. Find DF. Well, if you look at this picture, you have congruent markings all over the place. So if I'm focused on BE, B is a midpoint. E is also a midpoint because of how it breaks the sides up. So what that means is BE is a midsegment. So BE is a midsegment. And we know two things about the midsegment. It is parallel to the third side. So if BE is the midsegment we're talking about, then DF is that third side. So BE is parallel to DF. And we also know that BE is equal to half of that third side, which is DF. And I think the second one is going to be useful in finding DF, because if we find x, we can plug it in and find DF. So BE is 2x plus 6. That equals 1/2 of DF, and because DF is complicated, I'm going to put it in parentheses, 5x plus 9. There's my equation. I want to get this 1/2 gone. I don't want to distribute it because it's going to give me decimals. So multiply by the reciprocal. When I multiply the left side by 2, because there's multiple things, I put it in parentheses, and I distribute. 4x plus 12 equals, on the right side, the 1/2 and the 2 cancel, 5x plus 9 drop down. I'm going to then subtract 4x from both sides to get the x's combined. The 4x's cancel here. 12 equals, this is x plus 9, and then we'll subtract 9 from both sides. And over here, I get 3 equals x. So there's the value of x. So to find DF, I'm going to plug in x. DF is 5 times 3, which is the value of x, plus 9. That is 15 plus 9, which is 24. There's the value of DF. Okay, I'm going to scroll down a little bit. Now we have to find all the parallel segments. So this will be part B right here. And again, as I said, mid-segments are parallel to the third side. So here's one. Segment BE is parallel to segment DF. Okay. Now, we have more mid-segments up here because C is also a midpoint. Look how it breaks the side into 2 equal parts. So, AB is also a mid-segment. I'm sorry, not AB. I'm sorry. Gotta look at the middle. BE is a mid-segment. BC is also a mid-segment. It's parallel to the third side. The third side is AF in this case. And the last mid-segment is CE. And CE is parallel to the third side, which is DA or AD. And there's your all of your parallel segments in this picture. That is a mid-segment. Okay? This is all based off of the triangle mid-segment theorem, one of your important note cards to memorize. Okay, so here's our next problem. I wanted to include this because you might have something like this on the test, and I wanted you to see an example. This is from your book, and the question is, which school is equidistant from the subway stations at Union Square and 14th Street? So these subway stations are here. There's the 14th Street subway station, and here's the Union Square subway station. So we want to know what school is equidistant from these 2 points. Well, this is going to require a perpendicular bisector. Okay? And there's a theorem about the perpendicular bisector that says that if I have a segment, okay, here's AB, and I draw a perpendicular bisector through it, so it splits it into congruent parts, it's right angle, then any point on that perpendicular, say we'll put point P, the distance from P to A is the same as the distance from P to B. And that's exactly what I want to see, is what school is equidistant from A and B. So this problem boils down to constructing a perpendicular bisector of the segment connecting the 2 metro stations. So using my my marker. I'm going to go down this street. That segment connects both the two metro stations. So now I want to construct a perpendicular bisector of that segment. So I'm going to eye up a center, and I'm just going to call this the center right there. And I'm going to draw a perpendicular up and perpendicular down. So what I've done is I've split that into two congruent parts, and that is a right angle, perpendicular bisector. So the question is, which school is equidistant from those 2 points? Or which school is on the perpendicular bisector? And you see that Coleman School right here is the closest one. So your answer to this problem is the Coleman School. And again, because it is on the perpendicular bisector of the segment connecting the two subway stations that we wanted to be equidistant from. Okay, here we go. Next one. Find Y, ST, and TU. Okay? If I look at this picture, I see some markings. I see that this angle, SVU, is broken into two congruent parts. So this angle is being bisected. So there is an angle bisector here, and that angle bisector is the segment VT. So the angle bisector is segment VT. And it is bisecting this angle SVU. Let me put that in red. So what we have now is we have a point T on the angle bisector, which means that its distance from the sides of the angle are the same. These two segments are congruent. And this is by the angle bisector theorem. Okay, so angle bisector theorem, a point on the angle bisector is equidistant from the sides of the angle. So we know that 5y is equal to 3y plus 6. More, I guess from the picture we know that ST is equal to UT. So the distance, but we substitute and now we solve. Subtract 3y from both sides. 2y equals 6 and then divide by 2. And there's my value of y. Y is 3. So then to find ST and TU, which are going to be equal, I just plug it in. So ST is 5 times 3, which is 15. And that's also going to be the measure of TU. This is an angle bisector theorem problem. Okay, here we go. So it says, list the sides of the triangle in order from shortest to longest. All right, and notice they give us no information about the sides, but they do give us information about the angles. They tell me the measure of two of the angles. Well, I need to find the third angle. So by the triangle angle sum theorem, I can find the measure of angle M by adding the three angles together and setting it equal to 180, because the three angles of a triangle add up to 180. So the measure of angle M plus, this is 120, equal 180. Subtract your 120 from both sides. The measure of angle M equals 60. So there is angle M. So I'm going to put it in right here. So in order to put the sides in order from shortest to longest, I'm going to first put the angles in order from smallest to largest. So the first angle is angle O. That's 45, is less than angle M, is less than angle N. Those are the angles. So now it's just, what are the opposite sides? The side opposite of O is MN. The side opposite of M is NO. And the side opposite of N is MO. And here are the side lengths in order from shortest to longest. Okay, so here we go. Here's another triangle problem. This is a triangle inequality theorem problem. It says, can the triangle have the sides with given lengths, and explain? So let's recall the triangle inequality theorem, which states that the two sides of a triangle always have to be bigger than the third side. So you always just take the two smallest. So point out that 19 is the longest side. So all you have to do is add 8 and 10 and see if it's bigger than 19. If it is, it works. If it is not, it doesn't work. 8 and 10 is 18. Is 18 bigger than 19? No. This is false. So, therefore, these sides cannot be a triangle. No triangle possible. Alright. Okay, so here's the next triangle inequality problem. It says the lengths of two sides of a triangle are given. Find the range of possible lengths for the third side. So recall that, if we have a triangle, you have side of 8, 12, and x. Two things can be true. 12 could be the longest, or x could be the longest. So you need to check two inequalities. However, there's a shortcut. Remember, we put the third side x in the middle, less than, and then we do two operations with the sides we know. We do the subtraction to get the low value, and we do the addition to get the high value. And this is a simple way to find the range of that third side. 4 is less than x is less than 20. And to be fair, we should put feet. And there is the range of your third side, between 4 feet and 20 feet. Okay, last problem coming up here. It says find the range of possible values for each variable, and in this case we have a y in our problem. So if I look at these two triangles put together, so this is going to be a hinge theorem problem, hinge theorem, because it's an inequality in two triangles. If I look at this picture, I have one pair of congruent sides, and then these sides are also congruent. So we look at the angles we're focused on. Is this angle and this angle, the two angles in between. So the question is, what is the inequality between them? How do I compare 2y minus 7 to 28? Well, we have to look at the sides opposite of them. Now, there are no letters, so we just use the numbers. The side opposite of 2y minus 7 is 11. The side opposite of 28 is 12. Okay, fill in the inequality. What do we say? 11 is less than 12. So work your way up. If 11 is less than 12, then the angle opposite 11 has to be smaller than the angle opposite of 12. And there we go. 2y minus 7 is less than 28. And now we solve. Let's add 7 to both sides. 2y is less than 35 and divide by 2. Y is less than 17.5. And now this is the high value, right? Y has to be less than that, so 17 is the max. So now we need to find the low value. It's a range. Well, to find the low value, you take the smaller angle, and you have to make sure that it's greater than 0. Well, the smaller angle is the 2y minus 7. Has to be greater than 0. Add 7 to both sides, and divide by 2. And there's the low value, 3.5. So then, to finish your problem, and I've kind of worked right to left, to finish the problem, as we go over here, put your y in the center, 3.5 is on the left, 17.5 is on the right, y has to be less than 17.5, and if you think about this right here, 3.5 has to be less than y if you flip it around. So 3.5 must be less than y. And there's your compound inequality that shows the range of values for y. That's all based off the hinge theorem. Okay, thanks for watching. Hope this helped, and we'll see you on Thursday.